Hi, my name is Tom Hoeffel, and this channel is all about helping students learn chemistry. In this video, we're going to be talking about bond enthalpy. Now, there tends to be kind of like a misconception when it comes to bond enthalpy, and that's how bonds are broken and how they're formed. Okay, so if we have a lattice here, and we're trying to break some bonds within this lattice, when we actually break the bonds, it requires for me to put energy into the system to separate the atoms in this bond. Okay, so when it comes to being bonds broken, that's always going to be a positive number when it comes to energy. Now, when these two things come together and a bond is actually formed, that's actually where energy is released. Okay, and that's why I have a negative number here. So this tends to be a theme that lasts a lot in future units coming in chemistry, as far as like breaking or forming not just bonds, but intermolecular forces. If we break those intermolecular forces, that's going to require energy. But if we form those intermolecular forces, it's going to release energy. So this is not just for bond enthalpy. This theme, I should say, of things being broken and formed is actually going to exist in a couple other places going forward in this study of chemistry. Okay, so how do we use bond enthalpy, and what does it really tell us? Okay, well, when we use bond enthalpy, we use it to talk about the energy changes in a chemical reaction. I have a chemical reaction of methane gas. This is natural gas, so if you're in a chemistry lab, it's the gas that's coming out of the jets that supply your gas to your Bunsen burners, or in your home. A lot of homes are heated with natural gas, which is CH4. But the methane is going to combust with oxygen to form carbon dioxide and water, okay? And energy is going to be released. Now we show that energy release, okay? It's going to be as an enthalpy change, okay? So the word enthalpy, in layman's term, is pretty much like heat energy. And so when we break and form bonds, energy is absorbed or released as heat energy, okay? And that will also take place when we have these chemical reactions, because when you have a chemical reaction, bonds are broken and bonds are formed, okay? So why does all of this stuff fall in our bonding unit, okay, is because we're going to have these chemical reactions, and really we still have to do all these drawings that we just learned when we did ionic bonding and covalent bonding. Now, if you haven't watched those videos yet, I encourage you to go watch those videos, because what I'm about to do next is the things that were covered in those videos. So what I'm going to do below each of these chemicals is I'm going to do the covalent bonding that's required for each of them, because every single molecule up here is indeed covalent. So if I show the bonding for CH4, it's going to look like this. Now remember, there's an unequal share between the carbons and the hydrogens, so the dipole is going to be pointed towards the carbon. And once again, if you don't know how to do this, please watch the video on covalent bonding. Okay, so one of these methanes we're going to add it to two of the oxygens. Now, when we do our bonding for our oxygen, okay, it'll end up looking like this. And there's no dipole here, okay, because they share their electrons equally. Okay, but we don't just have one of these; we have two of these O2s. And when we mix those together, a chemical reaction is going to occur. We're going to form some carbon dioxide. I'll make that arrow just a little bit smaller so I can fit everything in here. So carbon dioxide, if we do the bonding for it, we kind of fill the octets of the non-central atoms, and then we're going to find out that the carbon's not happy. So we try multiple bonds. Of course, the oxygen is stronger than the carbon, so we got those dipoles. And then we got two water molecules, so I'm going to do two waters, okay? And each of the waters will end up looking something like this. Now, if you're in an advanced class, you'll realize that some of these don't have the right geometry right now. At this portion in our studies, we haven't done geometry. It's actually going to be the next chapter that we do. But as far as the bonding and the connections, this will work perfectly fine for where we're at this point in our study of chemistry. Okay, so now I'm going to take a red marker. I'm going to talk about the bonds that are actually being broken here. So in a chemical reaction, the chemicals on the left-hand side are called the reactants. Okay, and we're going to break all these bonds so that we get the individual elements. Okay, and then after we have the individual elements, we're going to form some bonds, but those are going to be the chemicals that are on the right-hand side of the equation, of which we call products. So we're going to form all of the bonds that are on the right-hand side, and we're going to break all the bonds that are on the left-hand side. So the type of bonds that we're going to end up breaking, let's talk about them. Okay, let's talk about our first molecule. We got our methane here, which is CH4. We're going to break this bond, we're going to break this bond, we're going to break this bond, and this bond. So that's a total of 4 carbon to hydrogen bonds. So I'm going to write that down. We're going to break 4 carbon to hydrogen bonds. For the O2, I'm going to break this double bond that exists between O2. And I'm not just going to do this one, but I'm going to do this one as well. So we're going to end up breaking 2 oxygen to oxygen double bonds. Okay, so this is what we're going to break. On the right-hand side here, so I'm going to kind of draw kind of like a divider, okay, we're forming bonds. And the type of bonds that we're forming, if we look at the carbon dioxide, we're going to form these bonds and these bonds. Okay, so this is a carbon double bonded to an oxygen. I got one bond here and another bond over here. So we're going to form 2 carbon to oxygen double bond. Okay, and then when we look at the water, what else are we going to form? We're going to form these oxygen to hydrogen bonds, and there's 1, 2, 3, 4 of them. So we're going to form 4 oxygen to hydrogen bonds. Okay, and we're going to look up the bond enthalpy for the average bond of carbon and hydrogen, oxygen to oxygen, carbon to oxygen, and oxygen to hydrogen. Okay, now these values, they don't have to be memorized. Okay, most teachers will give you a list. My list is right here. Sorry, I had to go off camera real quick. Okay, but this is the list that I'll give my students. Okay, your professor or your instructor or your teacher, okay, depending on what level of chemistry you're taking, should give you a list as well. These are numbers that you do not have to memorize. Okay, so I'm going to look up the carbon to hydrogen bond. Okay, and when I do that, it ends up being 413. So I got 4 of those. And I have 2 oxygen-oxygen bonds, and that value comes out to be 495. So I got 2 of them. So in my calculator, I'm going to take 4 times 413 and 2 times 495 and see what that totals up to be. Okay, it comes out to be 2,642 kilojoules. That was my input of energy to break all of these bonds. Now, I hope I get a return on that investment by forming all of these bonds. And I really just do the same exact thing that I did over here, but remember, we're forming bonds, so this number in the end is going to be a negative number. And remember, if you're breaking bonds, that number is going to end up being a positive number. So let's see how much energy is formed when carbon and oxygen are formed. So when carbon and oxygen are formed, that's 799. I got 2 of those. And I'm going to look up the oxygen to hydrogen bond, and that comes out to 463. And I'm going to do the same thing. I'm just going to total everything up. 2 times 799 and 4 times 463 gives me a total amount of energy of 3,450 kilojoules. Now remember, that's energy release, so I'm going to put a negative sign in there. Not saying that it's negative energy, it's just saying that this energy is being released when we form all these bonds. And really, to figure out your enthalpy change, you just take your bonds broken, okay, which is 2,642, okay, and you add it to negative 3,450, and that's going to be your return on your investment. And when you do that, you're going to get 808 kilojoules of energy being released. So we are going to say that this is exothermic. So all I did was took 2,642 and added negative 3,450, and that's what gave me negative 808 kilojoules. Okay. Now, when we have all this, okay, all this is saying is that when this chemical reaction takes place, okay, it's releasing a whole bunch of energy, and that's good because this is what's used to heat our homes. We want it to release energy. If this number ended up being positive, okay, we'd call that an endothermic endothermic chemical reaction, and we would have to supply energy, to make that chemical reaction take place. So this is kind of like bond enthalpy. There's another piece that some of your teachers or professors might make you do, and that's what we call an energy profile. Okay, so an energy profile is simply just a graph, okay, where energy is on the y-axis and there's absolutely nothing on the x-axis. Where did we start? We started out with methane and some oxygen. And what we did is we broke all those bonds, and that cost us energy, okay? So it cost us 2,642 kilojoules. So I'm going to put that in, 2,642 kilojoules. And what did we get out of that? Well, if we broke them all down, we broke them down into their elements. So we broke them down into the elements of carbon, hydrogen, and oxygen, okay? And then from those elements, we formed bonds, and we were able to release some energy. And we actually are releasing more than what we took in, okay? So we absorbed 2,642, but we're releasing 3,450. And then when we're done, we end up with our products of carbon dioxide and our water, okay? And the change in enthalpy is actually the difference between here and here. So if we started up here and we ended down here, that's going to be a release of 808 kilojoules. Okay, so that's an 8 right here. Okay, so from where we started to where we ended up, that was a decrease of 808 kilojoules, and that's an exothermic reaction. I hope this information helped you understand what bond enthalpy is. It's the amount of energy required to break bonds or form bonds. Okay, if you're breaking the bonds, it's positive. If you're forming the bonds, it's negative. And we use that information to figure out the enthalpy changes of these chemical reactions. If you found that this was kind of like straightforward information and straight to the point, please like and subscribe. This will help get this information to other students that want to learn chemistry in a straightforward fashion.